This is my dual stack. One of them is dead. I only have 2 of them working. This is my resonant capacitor bank. Without them, I would probably get about maybe 10-inch arcs, and I'd probably only be able to pull about 2 arcs, then the breaker would pop, just to give you an idea of how much more power it uses. But with these, I can draw about 2.5-foot arcs, and I can short it out for quite some time before the breaker pops. So that's my capacitor bank that makes bigger arcs and yet somehow limits the current to the input of the MOTs, which is pretty darn cool. And right there I have a MOT core, like top of an E core that I arc to, and that heatsink I arc to, but they do nothing. And that little board there is my Mazzilli driver. There's my ignition coil that's opened. That's what's inside an ignition coil. And a whole bunch of crap there. And 5 bazillion flyback transformers. So, let's see an arc there. And I'll see what it does to my power bill. Listen to that beautiful hum. My 60 hertz. There we go. Look at those big arcs. They're huge. This is the biggest arcs I've ever seen for a dual stack. See, there was actually sparks that time when I discharged. Here we have this poor baby motor. It's dead. It's made for about maybe 4 volts, but 12-volt car battery charger eventually burnt out the brushes, and I don't know if you can see that. Camera's not focusing anyway. But there's like a bunch of black there from sparks shooting out. So I think it's going to be cute. Since all of the insulation in here is pretty much burned out, I'm going to set this down there on the electrode, and I'm going to arc to a stinky little tip. Sparked that time. Very cute. Here we have a 10,000 ohm resistor. I think 10,000 ohms should be enough to resist 2,000 volts, because the higher the ohms, the higher the voltage you can put in before it draws current. So, let's give this a shot and see how she does. This is 1/2 watt, but since it's 10,000 ohms, it should limit a lot of current flow. So, let's see what all happens. 5, 4, 3, 2, 1. Oh no. Oh, that's just a real shame. Well, I wonder if it's still 10,000 ohms. Oh, here's the other piece of it. It's just a real shame. Well, since those were some pretty fascinating results, let's give that a zoom out, and we'll take a look at this again. 5, 4, 3, 2, 1. Ooh, yucky. Didn't smell so great. We're noob victim here. This is a 470 ohm 2-watt resistor. I'm thinking since it's 2 watts, maybe it can handle it, since it's can handle higher powers. I mean, it's less of a resistance, but it should be able to handle the amount of power we're gonna push through here. So let's see if I'm correct on this. 5, 4, 3, 2, 1. Look, it's arcing to my 1 electrode. There we go. I'm surprised current's not flowing through the resistor. Apparently it must resist pretty well. Let's give this a try again. 3, 2, 1. Nope. It's not really handling it well. So it's a good way to discharge capacitors though. Don't even have to discharge them. Oh well. Well, here's the results from it. It's a little bit discolored, I'd have to say. And it's still a bit hot to touch. Nope, it's not weak enough to break in half like my others. But, can you decode that? Gray or black, whichever one. Black, 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 black. What kind of resistance is that, and what kind of tolerance? I'm just curious what kind of tolerance it can handle now according to its new code. Yuck. Here we have a 1N4007 diode. It's rated at 1000 volts and 1 amp. I'm sure they can handle a little bit of overvoltage since MOTs produce about 2000 volts. But this is a dual stack. It can handle 4, but since they can only handle 1 amp and yet I've pushed 5 amps in, I imagine they can handle a few extra 1000 volts if they can handle a few extra amps. So let's see how good this rectifies this good short circuit. Five, 4, 3, 2, 1. Well, I have to say it rectifies pretty well. Because nothing happened, and I don't want to pop up the breaker by running that too long. And let's see if it's any warm. Make sure everything, okay, discharged. Oh, wow. It's not even warm. So I guess 1N4007 fast diode can handle it. That's our first thing that can handle it. Sweet.